and exciting time as we go through the program. Thank you. All right, so we are starting this amazing section. That is the final day of the ISTC 2025, and you are welcome everyone. Welcome Veronica, welcome Victor, welcome Dr. Dara, welcome Francis, welcome Daniel, welcome Suprati. Sorry if I can't pronounce your name so well, just bear with me. Welcome, Neil, you're welcome. Onja, you're welcome. Princess, you're welcome. Samuel, you're welcome. And you're welcome. You're welcome. On our video of Marvecx, just bring us into this section, and I want him to take on this conversation from here. So, Mr. Marvelous, the floor is yours.
All right. Thank you, Mr. Okiki, for that. Good morning, everyone. Good afternoon, good evening, wherever you are. Thank you for joining the last session of the ISTC 2025. Thank you for being with us from day 1 to day 4. Yesterday, how was our break? I hope all of us are doing our break. Okay, thank you all for joining the last day of the convention. Thank you all. So I will use this medium to appreciate all our participants. I will use this medium to appreciate all our guest speakers. And we have some of our speakers here already on the call in terms of Dr. Amole from Cross State University, in terms of Mr. Nate from Titan Space Industry, and in terms of Dr. Ashwara from Academy Innova World. Thank you for joining the call. Thank you for joining the call. Also, welcome our CI show participants. Thank you for joining the call. Thank you for joining the call. We have Mr. Ni in the call. We are on the call. We have Dr. Amole on the call. We have Dr. Ashwadara on the call. We have all our speakers on the call, which we also help in supporting you in terms of your projects to encourage you. If there's anything that they think that there is you need to work on, they will also encourage you on that. They are here to judge you. They are here to encourage you. They are here to help you. Thank you all for joining the call once again. Thank you. The floor is yours, Mr. Okiki. Thank you.
All right. Thank you, Mr. Marvelous. That's the CEO of Marvecx. Thank you so much for this welcoming message. So taking us further, I would like to call on the research lead of Marvecx, and he'll be done to tell us about the creative and innovative show, because that's one of the areas where you can see young researchers and other like real advanced researchers coming to present their programs as well. So I'll be inviting Francis Adedeji, that's the research lead for Marvecx. So thank you. The floor is yours, Francis.
All right. Thank you so much, Okiki. Please confirm if you can hear me.
Yes, I can, loud and clear. You can go on.
All right. Thank you so much. Right. First and foremost, I want to thank you for the opportunity to be here again. I want to welcome each and every one of you to the day 4 and the final day of ISC 2025. Thank you so much for our speakers for joining. Dr. Moloe, I see you. Thank you so much, sir. Dr. Ashiwaya, we see you. Mr. Neil, we thank everybody, right? So as we know, this is our last day, and so what we are actually having today is more like the CI show. That's a creative, innovative showcase, and it's actually one of the very pillar of Marvecx, right? On Friday, I made a presentation on Thursday rather about we having more like a research lead, a research point of us trying to bring innovations right in. So it's more like a platform to allow researchers, innovators, students to be able to present their ideas and whatever they have been working on. So this year happens to be the very first year where we're actually doing the CI show. And so we'll be having more like, we have like participants participating for this. Subsequent years, we'll actually be building out on this, right? So for this year, we have participants to register for the particular CI show, whereby we actually went through more like having some sort of panel to be able to examine the quality of research and innovation as first stage before they can actually come on to present, right? So for this CI show presentation, we have more like 3 participants and also a demo. So the 3 participants here will be coming up very soon. We have likes of Benjamin Yakini, we have Hudom, and we also have like Samuel. And so they will be presenting their innovative ideas. And afterward, we also have a demo from Dr. himself, Dr. Ashiwaya, to have a demo also for one of the works she has been doing also. So these are like the lineup we have for our CI show. So just for in order of housekeeping, right? I think the moderator will be able to host us or follow us through the particular process of more like who to speak with first and who will go first, the timing and the whole structure. And like we said, we actually want everybody to pay attention, to be on the lookout. It's possible that these particular innovators have 1 or 2 solutions for you, so you can pick them up and you also support them, and also more like open room for mentorship, and also as much as possible to have your own quarter of contribution and how they can be better. So it's one of the things we are trying to encourage here, to allow people to be able to, you know, aim for the skies, right? Aim for the skies, aim for the skies, right? So without wasting much of our time, I will now allow my host, Mr. Kijesu, to continue with the program. Yeah, thank you so much and welcome to ISC 2025 Emergence. Yeah.
All right. Thank you so much, Francis. Thank you for briefing us on what the CI show is all about, and that's our research lead for Marvecx. So the first participant that will be going on for the coming up rather for the CI show is going to be Benjamin Adebayo Yekini. Benjamin Adebayo Yekini. Yeah, before he comes up, I just want to give us the ethics of the CI show. So each participant have a maximum of 20 minutes to carry on with their presentation. And from there, we will have places where if anyone actually has a question or wants to contribute, then can come in. So let me read Benjamin Adebayo Yekini's profile. Benjamin Adebayo is an aspiring aerospace engineer currently studying at Lagos State University. He is passionate about advancing the field with a core technical interest in space exploration and propulsion systems. Demonstrating his commitment to development, Benjamin serves as the Learning and Development Coordinator for the Space Club at Lagos State University. He is driven by the clear goal of improving the aerospace sector. So Benjamin will be taking us on a topic which is on integrated radio frequency identification / near field communication luggage tracking system. So integrated RFID / NFC luggage tracking system. So Benjamin, the floor is yours. Thank you. 20 minutes, please. Thank you.
Sorry, good evening, everyone. I would like to ask if you can hear my voice, just to work on that.
Yes, you can. Yes, you can hear your voice.
And please confirm that you can see my screen.
Yes, you can.
Hello?
Yes, we can see your screen, Benjamin. Yeah.
Thank you very much. Okay, so first of all, I would like to tell you about how the whole idea came about. First of all, we all go through let's say we are all, or we would like to travel from countries to countries, and in this sense, why don't we have a smart luggage system? Now, luggage is something that we have to bring along with us, whether we choose to or not, be it clothing on other stuff. And in the process, we often, will I say, airlines sometimes miss luggage system, this luggage, and which lead to, what I say, suing and what I say refunding of these clients. And it's something that breaks the trust on the consumers aside of airlines and airport transportation. Now, this has been something that has gone on. Will I say it's a problem that we have faced, even way dangerous than, will I say, it has cost airlines way more than airplane crashes and other problems that airlines would face. Sorry, I don't know if you can see my screen, just to be sure, so I can go on.
Yes, you can go on.
Okay. So, yeah, airlines have lost quite a lot in the sense of luggage misplacement, and it has cost quite a lot. And I'm not really going to go deep into that, but based on my research, I can tell you that let's say an estimate of 5 billion has been lost from airlines all over the world, just by refunding and taking up, let's say, trying to curb the issues that come with luggage misplacement. And with this, I provided a solution, which is a smart luggage system. Now, the way this smart luggage system works, it helps airline to keep track of these luggages, as well as create a medium whereby customers can actually view the location of their luggage, and it helps to bring or build trust between customer and the airlines themselves. Now, why this solution is because without this, we won't be able to track our luggage. So I'm proposing a hybrid system, and it's can either be embedded into the luggage bag or can be attached to those luggage bag as a tag. The way it works, it utilizes an NFC technology and FRID technology all together at once, meaning I'm taking the good of both systems and bringing them in together one compact card. Now, the way it works is the NFC technology allows you to scan these tags, which can either be placed into the luggage or can be attached as a tag for customers that can't get the bag itself, the embedded bag themselves. So on getting to the airport for check-in, the person that would be assigning their luggage, their tags, and signing them in would actually scan these tags and impute their destination as well as their departure. Reason being that this would help airlines to keep track of where the luggage is supposed to go to and where it's left from. And on the customer side, the customer can actually use this an advanced FRID tag, which would be placed in it, but it would on the customer side, they can check the exact location of their luggage through the website. So on the customer end, all they do is just get the location of their website, but on the airline aspect, they can actually keep track of the location of the website, where it's left from or where it's departed from, and where it's going to arrive and the time of arrival. So they can actually track this bag along the way. And the accuracy, it's 99.9% accurate based on the fact that NFC is something that it's in existence and it's something that we're working towards working towards advancing in the future. And the reason why the reason why NFC and NFC technology allows us to work seamlessly is because it can be integrated with different systems. Now, different system in the sense that this bag can be tracked and can be located at all points. Now, the advanced tag protocol ensures that near perfect rates of versatility and overperforming legacy of NFC systems. Like I just said, the tags can be scanned seamlessly without any interference, and zero conflicts. The zero conflict prevents, for instance, let's say we have more than one bags in the same location. It won't at the FRID, because one thing about FRID, which is also known as the radio frequency identifier, can be scanned without being close to the bag. So we take out that aspect, because once there are more than one FRID tags in the same location, the scanner would be having confliction, and each bag would be beaming out identities, and it would conflict with the scanner. So what we use is we utilize the NFC technology for the scanning, then the FRID is for locating the bag itself. Now, the high throughput is processing hundreds of bags per minute without requiring a line of sight, speed up aircrafts through turnarounds and times. Meaning, one thing about airline is time is money, and if you can process a lot of passengers at the same time, you can actually get enough profits. And financial feasibility, in worst case scenario, 10% reduction of the millions that has been lost, which would actually, the airlines can actually utilize these funds that has been saved up and used for aircraft maintenance or other other expenses. And best case scenario, 50% reduction, which is fair enough for a start, and with time we get to advance these systems. Now, the market business, I'm aiming towards a global reach, which means airlines from all over the world can actually utilize this system to actually help speed up the process of luggage check-in and check-out, and ensure that the bags are exactly where they are supposed to be at the right time and everything. So, and it can actually work for instance, let's say cargo planes, whereby they have to take in bulk load of goods. And if, for instance, during check-in, you can, when you want to log the bags in, you can actually ensure that it's logged in the right plane and it's heading towards the right location. So that would also help in cargo aspects of airlines, as well as let's say for shipping, and in terms of logistics, it can also benefit in those aspects. So the implementation roadmaps, first of all, we get to reach out to airlines all over the world start small. Then what we aim to is reach out to airlines all over the world, tell them about the idea and how well it can actually benefit to the airline industry, and how it can actually help them move faster instead of just use the usual write-ups and procedure, which takes a long process. And sorry, the DMS integration, that's deploy the unified data management system. The reason why we'll be using a data management system is each tag would be assigned a specific let's say role in the data management database, whereby the details can be the details of each passenger can be filled in without let's say conflicting with each other, meaning the embedded tags would not conflict with the external tags. Each tag has their own unique code as well as their unique details that will be assigned to them. The way it works is for the embedded tags, the customer or the consumer can actually fill in their details, and that tag would be assigned to them permanently, meaning the only details that will be changed would be their place of departure and their destination they will be heading to. And for the external tags, they can actually fill in names of anybody, meaning once you check in, they'll fill in your name, your details, and they'll fill in your departure as well as your destination. Then on check-in, all they would do is clear out the whole name, like the whole details that was filled in, as well as the departure and destination. But for embedded tags, the only thing that would be changed is the destination as well as the departure. So there's zero confliction between tags and between users. Now, the third phase is the secure rollout. Now, the current century we are, or will I say the current age and time we are, cybersecurity is a thing of concern, and each tags and the way FRID tags are, they can be hacked, and they can be hacked, and details can be stolen from those tags. So what we are putting towards doing is creating those so that someone with the access from the database can actually edit those data, meaning once you get an embedded tag, you can only edit or fill in your detail once, and you won't be able to change them unless you reach out to the person, or you reach out to the company, which is us, to help you change your details, which would go through a lot of scrutinizing and checking if the details will be allowed to be changed. But for external tags, the airline would be in charge of changing the details, and the tags will be encrypted in such a way that only specific scanners can actually change the details on those tags, and meaning only the airlines will have those scanners that can actually change the details. But those scanners can't actually change the details on the embedded tags, meaning only the company would be able to change the details on the embedded tags. But for the external tags, only the airline, as well as the company that, like us, that will be creating those tags, that would be in charge of changing the details, which would most likely not be something we'll be doing from the company aspect, but from the airline aspect. Now, like I said earlier, passengers can actually track their luggage in real time, meaning while on board the plane, you can actually get the location of where your tag are. And let's say, for instance, you have to wait for your luggage has to be delayed. You can actually check exactly where your luggage is without being worried that your luggage is misplaced or anything, meaning you get peace of mind. And like I said, the tags can be utilized for other aspects. For instance, the NFC can be further advanced to check the weight of the bags, meaning those bags can, like, once you attach the for the embedded bag, sorry, the bags can actually tell the exact weight of goods that are inside them without you worrying that when you get to the airport, your bag will be delayed and your bag will be you have to pay extra for extra luggage. Like that was what I was trying to say. There won't be need for you to pay extra luggage, but that's a future plan. But for now, it's just sticking to the luggage, the smart luggage system. Now, I added some references to where I got the information, meaning my research. I, like, for instance, research on the amount of money lost from airlines all over the world, as well as the trend, baggage handling, the trend, and other resources which are used. So I feel this is a nice idea, which would actually help us solve the problem in logistics worldwide. So with that, I would like to say thank you for listening all through the way. So
Wow. That was really a remarkably insightful presentation. Please, let's just give him a virtual round of applause. That was very remarkable. Seeing such a young undergraduate doing, like, having that kind of research, it's really remarkable. Well done. So I would like our speakers and our top professionals, everyone on the call, to give their recommendations, because I believe that there's something that we've actually held on to that has been striking. So I just want one of us to just talk, and just as a way of also bringing another insight, maybe from our field of expertise as well. So please, the floor is for anyone. Dr. Moloye, Dr. Dara, any recommendation from your end?
Okay, good evening.
So,
It's a nice presentation from Benjamin Yekini. Thanks. I just have two comments and stroke recommendations. I think you should try to do a more detailed literature survey. That is, try to see if the idea, it's a wonderful idea, but I suspect there may be similar ideas somewhere around the world. So you need to do a more detailed survey to see what exactly has been done elsewhere, how they're going about it, so that it will also enrich your idea further. And then, although you did mention something about it, I think our advice to start small. You are, for instance, in Lagos State, where the major airport in Nigeria is located. Such idea can start off from that airport, and then try to take care of the local aviation industry. When that is going well, then it can also be scaled to the West Africa sub-region and gradually to the whole world. But that's a very nice idea. Well done. Thank you.
thank you so much, Dr. Amole. Thank you so much for the wonderful review and recommendation from him that I should get to have more literature survey and also try to start small. Yes, every great vision out there actually starts small. So that is very good. So I would love to ask if Dr. Dara have any recommendation from our hand. Okay. All right. So let me ask Neil. Neil, is there any recommendation from your end about his presentation?
Did you ask me?
Yes, I asked you this, Neil. Yes, any recommendation for him? All right. Thank
No,
you.
Dr. Tofik is right. It was an amazing concept. It is an amazing concept. But indeed, the first thing that came to mind is, did this promising entrepreneur do his competitive research. So he has to do indeed. Um, Anyone who is inventing something has to have has to do in-depth market research before even spending too much time in furthering its concept. So that was exactly what I would have suggested, Dr. Stovik. So we're on the same we're on the same side here. But it's an amazing concept, and what I understood is that he combines the strengths of the two leading technologies. So that could be an amazing eureka moment. But I don't know, and he has to research whether there are others who had the same idea. So indeed, he has to do a market survey. He has to do a competitive analysis. But I think it's very promising. Thank you.
All right, thanks, Neil. Thanks for the recommendation that you gave to him. It's really awesome. So thank you so much. And thank you once again, Benjamin, for that insightful presentation. So I believe that you actually had something to take home as an assignment for you. And I hope that by this time next year, during the ISTC 2026, you have been able for knowledge and also improve on these great ideas. So thank you, and we
By
really
the way,
appreciate that.
by the way,
Okay, maybe we can go on.
what's your name? Sorry.
Okiki Jason.
Okay, Jesu. Yeah, okay, Jesu.
Yes.
Maybe we should give Benjamin 2 minutes to clarify.
Oh, all right. Okay.
Right?
All right. Thank
Okay,
you.
thank you.
Okay.
Okay, thank
Benjamin,
you.
okay, so the floor is yours.
Thank you very much. So I actually did a little bit of research, but I feel it's not really well utilized worldwide. It's something that's growing, but all I would say is it has not been used to its full potential. So that's what I would say. They use it in logistics, meaning for companies use the NFC, like I said, but they don't really utilize the FRID tagging system. But yet, naturally, the tagging system.
All right. I think that must has been Benjamin's connection. I just give him some seconds to see whether he's going to be back. All right. So let's just proceed from here. Okay. So I would love to remind us that aside from the CI show, we still have presentation from one of our speakers. And lastly, we have our panel discussion, and it's going to be a very insightful one. So please don't leave the call until we are done with the panel discussion, because it's going to be very, very insightful. So moving on, I would like to call on our next participant for the CI show, and he's going to showcase his own research. So let me just read his profile. I'll be calling on Ubong Elijah. Ubong Elijah. Elijah is an undergraduate student of the University of Port Harcourt, Nigeria, studying mechatronics engineering. He also has experience in robotics and embedded systems.
Sorry. Sorry
Okay.
to cut you. Yeah, I'm back. I had a little bit of network issues.
Yeah, I don't know why I stopped when my network cut me off, but what I would say is I did a little bit of research and I got to find out that these systems are being used separately but not combined together in the aerospace sector. Yes, they do use NFC for luggage scanning, but not in sense of tracking. Yes, we have systems like let's say the AirTag that we use, but we don't use it like it has not been used combined together. So I'm proposing like a combined strength, and like I said, will I say I'm filtering out the weaknesses of these systems, then utilizing it in the aerospace logistics.
All right, thank you, Benjamin. That was a remarkable comeback from your end. Okay, so I believe our speakers are able to hear from his own end, and the little he has actually done from his own end as well. So thank you, Benjamin. While you were away, we've actually continued, but however, we still love what you are doing, and you're able to give more clarifications about it. So going further, I would love to call on the second participant to give his own presentation, but before then, I would love to read his profile once again. Udom Ubong Elijah. Elijah is an undergraduate student of University of Port Harcourt, Nigeria, studying mechatronics engineering. He also has experience in robotics and embedded systems, IoT, CAD, and project management and implementation. He has done multiple projects and has a lot of proposed ideas with his anti-mosquito device, being one of his many innovative solutions. He is a young Nigerian interested in increasing the quality of life of individuals globally with technology. He's presenting on the topic anti-mosquito device using thermal and UV attraction. Elijah, the floor is yours, please.
Good evening, good morning, good afternoon, everyone. Please, someone should please confirm whether they can hear me.
Yes, we can hear you. You can go on, please.
Thank you for this opportunity. Let me share my screen. Let me share my screen. So please, can you see me?
Yes, we can see your screen. Yes.
Well, let me go back. Okay. Can you see what is on the screen?
Yes, that is
Yes, we
correct.
can. Yeah.
Okay. Well,
Yes, yes, sir.
I'm going to talk about my anti-mosquito device using thermal and UV attraction. And well, it may not look like something for space exploration, but at the end, I'll link I'll make you understand why I chose this project for this space exploration, or a particular technology I used in this project that will be very, very useful in space exploration. So now let's talk about the problem first. Mosquito-borne diseases remain a threat in society. We all know, especially in Nigeria. Based on my research in World Health Organization, I discovered that more than 10,000 deaths as a result of mosquito, that is malaria, happens or occurs in Nigeria every year. That is, in a country as large as Nigeria, more than 10,000 people die because of malaria. And now, these deaths are human beings like us. So now we need to, I've discovered this is a major problem. And another thing I discovered is that most of the repellents or the traditional mosquito repellent system we use in this country, Nigeria, is mostly the insecticides, and we know that it's not actually convenient, and it's something that affects, like the odor itself is not even something that you you enjoy perceiving, those kind of thing. So now another thing I also observe is that this solution, the present solution for mosquito, is temporary, meaning it does not last for a long time. We all know that. So now especially in the insecticide, just for a while, when you spray it, After a while, you come into your house and you notice that there's no mosquito in your house again, those kind of thing. Understand? So now it is for a while, it's not for long. And so now I want to design a system that's a low power consumption system that can serve us better as human beings. Understand? I want something that is not just once in a while operation. I want something that is cheap and very, very affordable and will also show results. So now let me skip this one. I've explained this. So now let me talk about how this my project work. Okay. It's a device that mimics the human temperature. The human body temperature is between 38 degrees Celsius to 40 degrees Celsius. So now this my device comes with an inbuilt temperature management system that imitates the human body temperature. I'll explain how this imitation, how this temperature management works later. But now let's go to the next thing. It uses UV light. UV light is ultraviolet light. Understand? It's just purple. Understand? We all know that insects are attracted to light, but based on my research, this ultraviolet light now, let's say it attracts them because of the wavelength. It attracts them. Like they tend to want to know more about this thing. You are no longer sharing your screen.
Don't worry, go ahead, hold on. We're sharing the screen for you. Yeah, just continue speaking. Yeah.
Okay. So as I was, can you see it? Can you see it? Please, I want you to confirm. Can you guys see what is on?
Yes.
Okay, as I was saying before, ultraviolet light attracts mosquito over a long distance. That is science. That is just it. So now another thing I'm using is that I'm using a low power consumption fan. Normally, in most electrical mosquito repellent system, they use this thing electricity, to shock them when they come close, like a net that flows with electricity, and it's not actually safe. Understand? If a baby's in the house, those kind of thing, with touches get electrocuted, those kind of thing, and it makes noise. It makes noise. If you guys understand what I'm talking about, you know that the electrical this one that they used to use is to make noise when it traps or burns or electrocutes the insect. So now I'm using fan. I'm using the suction energy from a fan to pull the insect into a trap chamber. Understand? The body of the system has a UV light on it, and also the surface is warm. That is designed to imitate the body or the temperature of the human body. So this light attracts the mosquito over a long distance. Then when it comes closer to the system, to discover that this thing looks like it feels like a human being. It makes it comfortable to come close to the device or perch on the device. Then close to the surface of the device is a fan. Like, not that you actually see the fan, it's just that you feel, if you come close, you feel the suction energy of the fan. So let me explain it so that you guys can picture what I'm just trying to say. So it's like a container let's say a body. By the boundary of the body is a gap. So now that gap, before you get to the surface of the body of the device, you need to pass through that gap. And that gap now has a force, suction energy produced by a fan inside the device, that if you try to come close to the surface of the device, you will get pulled into that chamber or that space. You understand? Something like a black hole, those kind of thing. So now, when the mosquito feel comfortable with the device, let me say it want to attempt to suck the blood. When it come close, it will be pulled into that chamber. And now that chamber is a trap chamber, and I designed it how normally if it just pulls it into the chamber, it will not actually kill it or it will not do much. So now, but I how I designed the trap chamber is that once the mosquito enter inside the trap chamber, it cannot come out. And in the trap chamber, there's constant flow of air. So now my theory is that, because this is a proposed design, my theory is that the mosquitoes will be dehydrated. Understand? From my research, mosquito cannot stay, let me say, under constant airflow, which will lead to high emission of water, that kind of thing. So the mosquito will lose. One mosquito need water, according to my research. Mosquito need a lot of water. Like, without water, within 4 hours, mosquito is dead. They under airflow, within 1 hour to 1 hour 30 minutes, the mosquito is dead. So now my system is designed to suck them and send them to a trap chamber. It's more like a net pocket. So with the constant airflow, within a short period of time, the mosquitoes will die. And one good thing about my design is that it's an energy efficient design, meaning that it does not consume a lot of power, and it's self-sustaining, in the sense that I'm using solar power integration to charge the system. During the day, you go outside, you charge it. When you go back, when you go to your room, when you want to sleep, you keep it close to yourself, and it's just working for you. That is just the thing. And the fan is designed to produce not designed to produce noise. And the kind of fan I'm using is something that will not disturb somebody. And this my design is very, very safe and sound. So this is the key part, the heat emitter. That is okay. Now let me explain the heat emitter. The heat emitter I'm using like chrome wire with let's call it a mini or mini micro sorry, mini transistor. I'm using 555 timer. If you know what, okay, let me explain the 555 timer. A 555 timer is, let's say, an integrated circuit, an IC, that serves as a fast moving switch. We know the work of a switch. A switch is to turn on or turn off a power supply. So now, if you're using a pressing iron and you keep on turning on and turning off the switch for your pressing iron, notice that the temperature will increase and drop, increase and drop. If we observe very well, if we do that at a fast rate, you observe that the temperature of the pressing iron will be constant depending on the speed depending on the duration that you turn on and turn it off. I see the English is too much. So the thing is that the 555 timer is a fast switch. Understand? It's cutting the power supply following a period of time, and that time is programmable with a variable capacitor. Understand? The variable capacitor, you can vary the temperature depending on the speed. If you want it to be hot, you can increase the speed. Understand? You can increase the speed. If you want it to be a little bit warmer, those kind of thing, you will just reduce the speed, something like that. Then it also has the heat fuse in case the temperature, let me say, goes above 40 degrees. It's just cut it off. So now this is the temperature management system I'm using. I'm using a 555 timer and a fuse and a capacitor and all of the electrical components. And one good thing about this my design is its power consumption. Understand? It's designed to take, let me say, let's just say small amount of power, and it's self-sufficient. So now the UV LED light is just a purple light. That is just the thing, just a purple light that attracts mosquito over a long distance. While the heat emitter on the body will make them feel at home to perch then before they get killed. So another time using the fan, I've talked about the fan. The trap chamber is more like a net pocket, and it is removable. That is the thing. Every morning you remove it, dispose the mosquitoes, those kind of things. The power supply I'm using is a 3.7 volt battery and solar power integration to charge it. So I've talked about how the device work. Yeah, I've talked about it. So the innovation and what makes the device unique, that's what the innovation is about. It has a dual attraction system. It has a dual attraction system. That is the innovation. It has a dual attraction system. That is heat plus UV light. That is the technology I'm talking about. Heat plus UV light. This will increase the attraction. You know that one thing about mosquito is that they adapt as home living things. They adapt, and nowadays mosquitoes, present mostly in Nigeria, adapts to insecticide. That is why you notice that when you spray insecticide, 30 minutes time they are still there because with time they will adapt. But my device, mosquitoes cannot adapt to my device because they are always fooled. They are always deceived that this is a warm body, this is a human being body. Because one thing that attracts mosquitoes is the human body temperature. That's why they come close to you. And another thing is the carbon dioxide produced from your nostrils. That's why sometimes they try to come close to your nostrils. You not hear them singing in your ear, those kind of things. So now they are attracted to our body because of our carbon dioxide emission from our nostrils. They're also attracted to because of our sweat, the octanol, something called octanol in our sweat and body oil. And they're also attracted to that thing, and they're also attracted to our body heat temperature. That's why they're able to know the difference between the human being body and a pillow. So my design is low power consumption. I've talked about that. Then let's go over to the next slide. Next slide. Well, the next slide is the technical advantages. This my product is affordable, durable, and it's an affordable and durable component. Yeah, meaning it's cheap and it's designed to last long. That is one thing. And it is safe and user friendly in the sense that it does not emit offensive odor like all these insecticide, and it is safe to use, unlike all these electric tasers that they use for to trap insects, kind of thing. It's not safe. Me, out of experience, I've experienced a lot from that kind of thing. So, and another unique thing about it can be used indoors and outdoors, and it can be easily mass produced. Because me, actually, I am a kind of productive person that actually thinks about mass producing. This thing, I know, just like idea, something that is a problem I identified and brought about a solution. So it's something that is very easy with the design. We'll come to the page of the design very soon. You see, it's a portable design and those kind of. It's a good product and it can be scalable. It can be increased, multiplied, anyhow. So let's go back to the next. Let's go back to the next slide. Let's go back to the next slide. The next slide is talking about the expected impact. Yes, the expected impact. Well, my product is going to bring about safer nights, sleep comfortably. At least it will reduce the number of mosquitoes that will be attracted to a human body. Let me say in a room there are 10 mosquitoes. Because of the light and the design, the technology behind my product, it will be attracted. Let me say about 8 to be attracted to my device, then like 2 can go back to the later, the 2 still come back to the device. That is that one is for sure. And my device help prevent malaria. Malaria is actually in Nigeria. For my research in World Health Organization, you can still go and check it. 2024 malaria fact, World Health Organization. You discover that in Africa, 39% of deaths as a result of malaria is from Nigeria, which is too much for a country. As I said earlier, 10,000, like initially, I did not even know that this amount of deaths this is actually a problem. I don't know this amount of death because malaria is something that me, I've experienced malaria a lot of times, something that I'm going, how will I say, I'm immune to it, this kind of thing. But I discovered that people die because of this thing in Nigeria. So it's a problem that needs solution. And this is a, how will I say, this is like, let us say, one of the best solution to this problem. Something that is long lasting and something that is convenient for human use. So now this my system also provide clean alternative to repellents. Normal typical repellent, we know all know that is very annoying. Like that thing is something that very if self I think it's a poisonous gas because if you hear that thing you play like you feel an effect in your body. That is just it. So now
Sorry, Mr. Elijah, you have extra 5 minutes
okay,
to go.
thank you. Okay, okay. This is also useful for homes, farms. Next slide, please. Next slide, please. So this stage I am now is just the concept and early sketch. The next stage will be the building the product, testing plan, heat fabric calibration, mosquito attraction system. Let's go back to the next slide. The next slide is about my financial projections. The cost is about 9,000 naira, selling price 10, 11 to 13. These are about the profits. Next slide, please. Next slide, please. So now the device keys. This is what it looks like. This is what it looks like. This is what it looks like. This is trap chamber, 200 ml capacity, heat emission. This is human skin temperature range, profitability and business model. This is about my. Let's go back to the next slide. Next slide, please. The next slide now. My target customers is mostly homes, families, schools, and hostel and medical centers. That is my target market. My value proposition, no chemical, low. I've said all that. Channel. When I'm planning on working with Jumia, I currently have a market with them. I'm planning to use them to distribute it mostly in Africa. This is what it looks like. Please, next slide. Next slide, please. This is what it looks like. This is the whole body. What the next image you're seeing there is the top cylinder and trap chamber. The top cylinder you're seeing there is where the body, where the heat. That is the part of the device that will be mimicking the human temperature. We can see the third image is the chamber. Then the next one is the next slide, please. Next slide, please. So the challenge is optimal heat control, how to control the heat, and I've told you guys about my temperature management system with Nikon wire and 555 timer, power efficiency, material durability. I use thermal fuse. The thermal fuse is in case of high or change in high temperature, it will cut it off. I've talked about other ones. My future improvements is I'll add octanol attractants to attract it to attract more mosquitoes towards this thing. Then I'll use a mobile app for better user experience, wireless charging. I'm also planning on integrating wireless charging to prevent wear and tear of cables, because using cables to charge it sometimes is kind of annoying, because sometimes if it's not properly charged in the sun, you need to use cables to charge it. But charging with cables is something that it's not really cool and those kind of things. But I'm also working on wireless charging on it. So now let's talk about it on space. This is the last thing I'll say before I'm done. So now managing temperature or thermal management in space exploration is very, very important. Now, if you're talking about the application of my project in space exploration, this is the part, because temperature management in space is very, very important, because sometimes you need a controlled environment. There are some part or components of the space equipment or whatever is involved in space equipment that will need, like, has a temperature limit. You understand? So if you have a way to control the temperature, it will be applicable there, and also to notify you when a particular temperature is a particular temperature. Like this thermal fuse now can be used there. Although thermal fuse is already used, already something that's already used. But with this my temperature management system, you'll be able to use or manage temperature in space. Yeah, you'll be able to manage temperature in space. If you're using let me say you want to design the controlled environment for biological experiments, those kind of thing. You want to regulate temperature, yeah, you can just do regulation of temperature with just a button or those kind of thing, making management in a way easier and just better. But in a way, it's applicable in space exploration. Next slide, next slide, next slide. The next slide is my conclusion. You can go to my conclusion. I just finished talking about the application in space space. So you can go to conclusion. Well, the conclusion is summary of what I just said. This is a solution to a problem in Nigeria. And before we even talk about space exploration, we need to talk about making people's life better. Understand? Because when people's life are better, that's why you now have people that are comfortable enough to go for the space exploration, those kind of things. So this is just, and the next thing is reference. This is where I got my information from: World Health Organization and mostly other food industry for the UV LED and low power data sheet. Well, thank you very much for the opportunity. Especially Francis, you really helped me. Thank you very much. Thank you very much. Well, any question, because this is all I have to say. I'm done. Thank you.
All right, a round of applause, a virtual round of applause for Mr. Elijah for the wonderful presentation. He was talking on anti-mosquito device using thermal and UV attraction, and I believe that we actually followed through his presentation. So I would actually want our speakers to actually give recommendations for the presentation he has actually made. So if there's anything that we can actually add and maybe at least he can actually improve on. So first of all, I'll call on Dr. Amole to just give him a form of recommendation. Thank you, Doctor.
Okay, thank you. Thank you, Don, for a good presentation. Yes, malaria is a big problem in Nigeria, and of course, the prevention of malaria is a good thing. I think similarly to the first presenter, there is also going to be a need for a more in-depth. I think Nels called it in the usual industry way, but in the education aspect, literature review, like a more in-depth literature survey, just to see how your solution that you're proposing is going to be different or even better than whatever is already out there. I know there was something that I have used before that may have a similar concept as what you are proposing. I'm not sure if the concept is exactly the same, but again, it just goes to show that you need to do a more in-depth survey to see what is already out there and what is the new thing that your own device is proposing to bring to the table. I was going to say he would need to do more on the CAD because for a very long time when he started his presentation, I was looking out for the CAD design. It would have been quite useful. But later on, I saw it. I think it may still need some more of work, the card design. Those are the two things from my end. But overall, thanks for the presentation.
All right, thank you so much, Doctor, for the recommendation given to Elijah. I would love to call on Rama. Rama, please, do you have any recommendation for Mr. Elijah? Okay, so I think Rama is engaged with business. So I would love to call on Neil. Neil,
Yes,
do you have
sir.
any recommendation? All right, thank you.
The presenter's name is Elijah, right?
Yes.
So Elijah, I have to, compliment you on your vision, because this is about saving lives. And that's just like a doctor, you are thinking about saving lives, not about money. So this was, Dr. Rama was muted. So I'll keep this short. But I want to comment on Elijah's vision. It speaks to his character that he wants to solve an amazingly important solution. It's a huge problem, as Dr. Tofik just said, and as Elijah stated. I think he said 10,000 people per year die from this, from mosquito-related diseases. 10,000, Elijah? Is that in Africa or in Nigeria?
That is just in Nigeria. If you can hear me, that is just in
No way.
Nigeria alone. More than
My God,
10,000.
brother.
10,000.
I commend you for this vision. So, technically, if you have in your own experience, if you have seen the lack of a solution, that means you are on the right track. Because there are still 10,000 people dying in Nigeria. And how many in Africa and South America and so on. So your vision is maybe timely, but also very needed. So, brother, you should, you know what, connect with me on LinkedIn. Because if you don't want to become a billionaire with this device, you should go to the non-governmental organizations and or donors and contributors who are not looking for a profit. I love the fact that you said this is low cost. I cannot translate that to US dollars. Can you do that for me, please? How much is it?
US
You
dollars.
said the cost is 9,000. Sorry?
It's about 11,000 naira. That is, I am approximately, let's say, $7.
No way. See, you should check out with the Bill Gates Foundation. I think it is now called Bill Gates Foundation because they separated Melinda and Bill Gates Foundation. But that kind of approach, brother, I will support you. Okay, so connect with me on LinkedIn, and I'll guide you through stuff. Okay, because you're doing God's work, and I'm not a very religious person. Yeah, so
Okay.
let's make this happen. Well, check out my name on. My name is Neil,
Okay.
Neal. Sorry? Yeah,
Oh,
connect with me on LinkedIn. Neil
all right.
Lachman, okay?
Elijah, no problem to connect with Mr. Lee on LinkedIn.
Yes,
We will
please.
drop his
Yeah,
LinkedIn
Marvelous,
handle on the chat box.
Marvelous and I
Okay, okay, yeah, yeah.
communicate
Yes,
all the
so
time.
Francis will reach out to you.
Okay, go ahead with
Yeah,
the
no
next
problem.
person.
All right, thank you, Mr. Nin. So, calling on last speaker to give us a recommendation for Elijah before we move on to the next CI showcase participant. So I'll call on Mr. Rahman to come and give his own recommendation. All right, sir, the floor is yours.
Thank you for that. Can you hear me?
Yes, we can hear
Okay,
you.
perfect. Yeah, okay, sorry. I was just muted and I was trying to speak. So it was a very well presented and it's a very good social cause for which he's trying to bring out a solution. And I think the connecting the space to a social cause is something everyone should keep in mind moving forward. And in that direction, it's a very good presentation and I appreciate the efforts. And I think some other inputs are already given, so I'll cut it short. So very good, very well done. Keep it going.
All right, thank you, Rahman. Thank you so much. So without wasting time, let us go to the third participant for the Creative and Innovation Show. So the third person that will be coming on is Samuel Buinde. Samuel Buinde, I'll read his profile. Samuel is an aerospace engineering graduate. He graduated as a top 3 in his department. He's passionate about STEM learning and space exploration. He's impacted lives through tutoring and mentorship. Currently promotes space awareness with African Space Foundation and Universe. Space and serves as the spacecraft aerodynamics engineer at National Space Research and Development Agency of Nigeria, that's NASDA, during his youth service program. So we'll be coming on to talk to us on his presentation, which is on design, optimization, and static thrust testing of a custom propulsion engine for a model sounding rocket. I'll repeat that again: design, optimization, and static thrust testing of a custom propulsion engine for a model sounding rocket. So, Mr. Samuel, the floor is yours for 20 minutes. Thank you.
All right. Hello everyone. Can you all hear me?
Yes, we can hear you.
Right, great. So I'm Samuel Boinde, and I'm going to be sharing my screen in a moment. Okay. All right, confirm if you can see my screen.
Yes, we can. Yes, we can.
All right, thank you very much. Okay, so yeah, the title of my presentation, as earlier stated, is Design Optimization and Static Thrust Testing of a Custom Propulsion Engine for a Model Sounding Rocket. Sorry about the length, it's quite lengthy, but then let's move on. Okay, so generally speaking, rocket science and rocket performance is something that is really important in our current dispensation. And like the way Blue Origin and SpaceX are trying to, well, I'll call it more like almost a competition, right? But then one of the major things that is considered in a rocket design is the geometry and also the amount of thrust produced. And also in most African countries, especially Nigeria that I am in, there isn't so much of pronounced rocket science activities. And also, the nation and many other countries in Africa have been focusing on, foreign rocket technologies, just like some satellites being launched by another country for another country, if you know what I'm saying. So yeah, basically in Nigeria and in much of Africa, there is limited access to rocket testing facilities, and especially for universities that are offering aerospace engineering in
most of these schools. Someone reached out to me on LinkedIn and was talking about the fact that there is less of opportunities in aerospace engineering in their country. And I was like, oh, well, it's almost the same thing everywhere. So basically, this project addresses the gap of, the practical possibilities, because there is little or no testing facilities. If at all you see any testing facilities for rocketry, it's probably a government organization. You almost won't see one. And also, this project also addresses the gap of developing a low-cost, locally built sounding rockets and thrust test system, and the innovation and skill development. And beyond the local impact, it's basically contributes to the global aerospace research and supporting low-cost space access. So yeah, how can we develop and test an efficient rocket system using low cost and locally made available resources? So yeah, basically, in this project made use of indigenous technological development, in the sense that I made use of locally available materials. I didn't have to, order things from, the US or China, like some model rocket launchers do. And also, the low cost innovation for space research, and the possibility of the capabilities of rocket science in Africa and as well. So this project is to study the effect of rocket geometry on aerodynamic performance using CFD. That's I majorly used ANSYS CFD to carry out the simulation, and also to identify the most aerodynamically efficient rocket design through comparative analysis, and also to design and fabricate a custom rocket itself, and also a propulsion engine suitable for sounding rocket application. As we know, most of rocket builders or model rocket launchers, they tend to purchase their rocket motors online, maybe from Roxane, and most of all those things, you need some kind of licenses and some kind of eye security profile, just to make sure that you're able to purchase. And they're actually very expensive to purchase, depending on the grade of rocket motor that is being purchased. And yeah, also to develop a low-cost static thrust test stand using a locally sourced component, and to demonstrate the feasibility of locally developed propulsion research infrastructure. Yeah, so how does rocket geometry influence aerodynamic drag, lift, and stability? So basically, to launch a rocket, or to, in the aerospace field generally, one of the things that we are after is reducing drag for any body, that's any vehicle that we're actually like designing, and also increasing the amount of thrust being produced by that vehicle, whether it's an aircraft or a rocket, which is the major concern in this project. And also, can a student built engine meet the performance requirements of a sounding rocket? Well, we'll see about that as we go along. And yes, can thrust be measured accurately using a low cost? Definitely, we'll see. All right, so the first thing I did was to go through different design stages, which was basically having to vary about 4 different types of fin and 3 different type of nose cones. And the 4 fins were the delta fin, the trapezoidal fin, the tapered swept fin, and also an elliptical fin. These 4 models that you see here were actually the ones that were more like, let me say, shortlisted, because from the comparison, from the the combination of those 2, I had like about 12 different models. That's why you see Rocket 12 over there. So those 12 different models, simulations were carried out and then was brought down to 4, of which 1 was picked eventually. So yeah, that's basically the ANSYS mesh over there. So yeah, this is also the engine and the test system. So by the left-hand side, that is the rocket motor, with the rocket motor with also the nozzle behind it. And by the right-hand side is the measuring system, which has the rocket motor to the load cell transducer and HX711 converter, Arduino Nano, the power source, the battery, and then also an SD card module for logging the data, because of course you don't expect a person to stay in that amount of vigorous fire, that exhaust that comes out from a rocket's motor. So yeah, this was the results gotten from the ANSYS simulation, the drag, and the lift, of which I got the drag coefficient and the lift coefficient. Now, in this case, so the image that you see there, the graphics there is for rocket 2, that's R2 that you see over there. I couldn't put, all the images because it will just look so congested. So yeah, the angle of attack in this case, as we know, generally speaking, angle of attack is just more like the angle between the free stream velocity, the incoming air, and also the surface that it is touching, or the reference point from which the reference point where the air is touching. So yeah, in this case, the angle of attack is actually representing the deviation from the rocket's trajectory. So normally when a body is moving in air, there is always some things that disturb it in the air, like, most especially wind and the weather and different things like that. So in this case, the disturbance is actually the wind impact on the rocket surface. And the more the disturbance, the more it tilts away. And that tilting away causes a deviation from the actual trajectory. And that deviation keeps increasing in angles, of which I have 0, 5, 10, and 15 degree angle of attacks that were checked. So in every flight, in every build, what is understood for aerodynamics principle is that when the lift increases, the drag increases. And for every design, the aim is to have an increased amount of lift, of course, moderate to a good extent, with reduced drag for the aerodynamic efficiency of that body. So that is majorly what I checked out for in all the results that was gotten. And if you look closely, Rocket 9 and Rocket 12 add lower amount of drag, at higher angles of attack, because we want lower drag at higher lifts. And also, that the more the lift, the more the possibility of a flow separation, which could cause a stall, and in this case could cause the rockets to tumble and also crash, which definitely will be so expensive to recover from sometimes. Well, SpaceX is quite rich, so I guess that's why they went through a lot of crashes at some point here. So yes, but then if you look closely, Rocket 9 actually exhibited a consistent reduced amount of drag at higher angles of attack. And also we want lower lift and lower drag even at those higher angles of attack. Now, Rocket 9 at angle of attack of 15, it has about 229.6128 of drag in newtons, and also the lift of 446.6490. Now, one could have imagined, why didn't you go for Rocket 12? Why Rocket 9? Rocket 12 actually even has an elliptical fin, and elliptical designs generally are very difficult to produce. But beyond that, we are actually after the value of the drag that we get. So moving on, and if you look at the right-hand side, those are the visualizations of the experiences at every angle of attack. Now, from all this data that was gotten, Rocket 9 was the best option to have gone for, which has characteristics of a parabolic fin and a parabolic nose cone and a trapezoidal fin. And if you look at majority of the current rockets that are being launched or spacecraft, you would see that that is actually the designs that they do go with. So yeah, the first image there is the one at 0 degree angle of attack. And basically, it's just going straight. And then 5 degree angle of attack. Now, if you look closely at the 5 degree angle of attack, you know that when lift is being generated, there is always an area of, high velocity and low pressure area. And by the right and by the other side with, the kind of green color, that's the pressure contour. And then by the left-hand side with almost like orange color, that's the velocity contour. So yes, you'd see closely around this side that there is more like a lot of like high velocities at those 2 points here and here, which means yes, it's already experiencing lift. And also, when you look more closely at the body, the boundary of the rocket, you would see some kind of like lines towards that side, almost separating from the body. That is the flow separation happening gradually. And for 15 degrees, you see that it is more pronounced, right? And which means that at this point, we need to start watching and make sure that this rocket is more optimized to get a proper performance. So moving on, yes, so this is rocket 9 that was eventually picked. If you notice, this rocket is actually longer than this ones that were shown here, right? Now, what happened is that here I already did some optimization, which included increasing the length of the rocket. The initial rocket was having a total length of 0.8 meters, and this particular one has a total length of 1 meter. And now it also has an increased number of fins. If you look at this one, it has just 3 fins, right? Even though increasing the number of fins will increase the amount of drag that is produced, right? What I did to compensate for that was the increased length of the body tube, right? So basically, it has, it's characterized by its trapezoidal fin design, consistently demonstrated low drag, like I said earlier, at higher angles of attack. So this is the thrust measuring system. Now this is the static stand with a wooden base, and then you see the black part where it is touching. Let me just zoom in. Right, okay. So yeah, this is more like the holder for the rocket's motor. And then this wire is just for the ignition system. And looking at the other side, you would see what is inside the box for the measuring system. So yeah, behind this black surface, you'd see the load cell transducer, and also we have the microcontroller, the power supply, the HX71 converter, and also an SD card module for the logging of the data. All these things, all this setup was at a very, very low cost. Now, yeah, let me just move on. So basically,
sorry, Mr. Samuel, you have less than 4 minutes to go. So, yeah.
All right, sure, no problem. So yeah, sounding rocket research, it's one of the things that is used by students, especially for aerospace engineering students and mechanical engineering students, into propulsion and just to measure some flight data or atmospheric data, and also a possibility of having a small satellite launch prep, and also experimental just for, it could even be for classroom work, just to help the students understand things better. And also, STEM education like I'm into, and also university research and innovation hubs and training for students and young professionals. So yes, the future work, integration of onboard sensors. Now for the rocket model, it has actually been developed. You would see it after now. It has been developed already, and it has onboard flight computer that measures the gyroscope. It measures the altitude, pressure, temperature, and velocity, and basically, and also the acceleration. So the flight testing of the full rocket, that was meant to happen about 2 months ago, there about around September, but due to some challenges, it was cancelled for that time and postponed to a very closer time, very soon though. And yes, the possibility of using a composite material for the body tube, just for the durability and the possibility of being able to use it more often, and the engine efficiency improvement. The rocket engines performed well. You would see it after now, but then the thrust gotten could be much better and could give more results, which I'm hoping to work on subsequently in my future projects, and also partnership with space organizations like NASA in Nigeria and a couple of universities, just to help their aerospace engineering students understand things better. Because most times students will tell you, oh, they love the astronautical engineering side of aerospace engineering, but there isn't so much of resources for them to learn what they actually want to go into beyond the theoretical things that they learn on MATLAB and, just basic things that don't really, allow them to see the practical aspects of things. So yes, this is the static fire test. Some of the static fire tests. I carried out about 12. You'd see that more than 12 actually, but this is for static test 11 and 12. 12 is by the left-hand side and 11 is by the right-hand side. So I will be playing. I'm going to play for 11 first. Okay, so that is the thrust curve. This is for 12. Okay, so for both testings, there were some kind of like fails because for this one and this 11 and 12, I used PVC for the body, for the rocket's motor. But if you see from what I showed here, so that I already changed it to an iron rocket's motor just for the sake of the durability and the possibility of using it more often. And also the nozzle, which is made with steel, which was fabricated with a CNC engine, CNC machine. So this is rocket 9, which is designed fully to scale. The nose cone, which is about 0.2 meters, the length of the body tube, which is 0.8 meters, making the entire length 1 meter. And if you look closely, I'm not sure you might be able to see it, where my hand is actually covering here, that is where the flight computer is. It was meant to be screwed anyway, but then since it's not yet time for launch, I just used my hand to pad it just so that it does not open. And here is the the launch pad. Okay, sorry about that. Okay, so efficient rockets can be designed and sorry. All right, sure. Efficient rockets can be designed locally from what has been shown in my work, and engine performance is tested affordably because I purchased most of the things locally, if not everything actually. And Africa can definitely build space capacity. Students can lead innovation. Thank you very much for listening.
All right, thank you so much, Samuel. Thank you for that wonderful presentation. That is absolutely visionary. I really love your presentation. So I would like to call on Mr. Lee to just give a recommendation. All right. Lee, please, you're on the call. You can actually give Samuel a recommendation. Thank you.
Wow, great. I'm very happy to do that. Samuel, amazing job and keep going. As an astronautical engineer myself, the work that you're doing to understand the fundamentals and the physics behind the engineering that you are studying is absolutely incredible. There's nothing like the hands-on work that you're doing that will pay off huge dividends in the future. So my biggest thing is keep going, keep reaching for the stars, and bring your country into orbit. It's fantastic. Well done.
All right, thank you so much, Neil. Thank you so much, Lee. And the last person to give us another recommendation is Neil. So if you're on the call, you can just give Samuel a short recommendation. That's a short one. Thank you.
No, impressive, and I concur with Lee. This is fundamental work. So great job, and a great explanation. Was thorough, but easy to understand. So I had one question, by the way. I saw quite a messy environment there with the testing. So you should be careful with that, brother. I don't know why you did it there, but you have to have a clean environment. You don't want stuff to get on fire and that would be basic precautions I don't want to lecture you. You may have your reason why you did it there, but be careful, please. For the rest, very professional. You know what you're doing, and you're going to achieve lots of great stuff with this approach of yours. Thanks.
All right, thank you, Neil. Thank you, Neil. So the last person to give us a recommendation for Sam's presentation is Dr. Hamole. All right, sir, Dr. Hamole, you can have the floor.
Okay, thank you very much. Oh, that was a very good presentation, Samuel, and I totally enjoyed the concept, everything. I would just also advise that, yes, you have to be more careful when testing. And also, it would be good to see this in a publication. I don't know if you have tried to put this together and publish in a paper. I mean, it will also help to spread the knowledge that you have gained from this processes to a larger audience. Have you done some publication from this, Samuel?
Well, not yet. I tried once, but they requested that the rocket be launched first.
Okay. Okay. Well, let's keep in touch. We can work together.
All right, sir.
Yeah.
All right, Dr. Amole, thank you for the recommendation. And Samuel, thank you for that wonderful presentation. I believe you've been able to have more ideas about population and also to be careful about your environment. So nice projects from your hand. All right, so we would have loved to take on the next participant to give us a demo presentation for the CI show. However, because of Mr. Lee's tight schedule, we will actually want to call him first to give us his own presentation. Now, his own presentation is not for the CI show. He's actually coming to talk as a speaker just for 30 minutes. So, Dr. Dara, please just bear with us. Once Mr. Lee is done, we will actually bring you up for your demo presentation. So thank you for being with us. All right. So, Lil, yeah, the floor is yours. Thank you.
Yeah. Great. Thank you. Oh, yeah. Go ahead.
Should I go ahead?
Yeah, Lee should go ahead.
Yeah. Okay.
Dr. Dara, when Lee is done, we will bring you up. Thank you.
Okay. Okay, fine.
All right.
Great. Thank you so much. It's really an honor and a pleasure to be here speaking to all of you. I think this is an amazing forum. As you just saw, you know, the field of rocketry and space is expanding globally. You know, obviously started you know, many years ago in the United States and the former Soviet Union and things like that. And it's wonderful to see this expand throughout Europe, Africa, Asia, and other places. So congratulations to all those that are working to expand humanity's reach into outer space. I really think that's super important that this become a global effort, because the future of humanity truly depends on it. So what I'd like to chat with you a little bit about today is the work that we're doing at my company. We're called ThinkOrbital. We are based in Boulder, Colorado in the United States. And, you know, we are overcoming one of the fundamental constraints of outer space, and that is the size of things in outer space. But before I get there, I'd like to just chat a little bit about what got me to this point, because I think it might be helpful to some of the students and things like that as we go through this. So my background, I served for 23 years in the United States Air Force as a space engineer, acquisition officer, and operator. I did multiple assignments at Space Systems Command. I was the commander at both Vandenberg Space Force Base and Cape Canaveral. So had the opportunity to launch a lot of rockets during my time in the military as well, and work on several space systems. I retired from the military in 2011, and then I was at SpaceX for 11 years. I was the vice president of launch and mission operations. So we got to build launch sites, you know, build and launch over 200 large rockets and payloads into outer space. got to send 22 good friends into outer space and bring them home safely, which is really one of the honors of my career. And while we were doing these things at SpaceX, you know, we talk about the constraints of outer space, as I mentioned, and you know, one of the constraints was getting to outer space. Now launch is everything we had kind of dreamed of. It's reliable, it's affordable, it's super high cadence. You know, this call is coming to you over Starlink. So for $100 or so a month, anywhere just about on the planet, you can have 250 megabits per second data at 50 milliseconds latency just about anywhere. So there's another constraint that's kind of been eliminated, getting data down from outer space. And in my estimation, the next big constraint that we have to overcome is the size of things in outer space. In space, everything is tiny compared to any terrestrial application. You would never build a factory on the ground that's 70 feet long and 20 feet wide, or, you know, 30 meters or so long and 5 meters wide for those who speak in that system, because you can't scale it. And one of the things that we are working on is scale. You wouldn't build the Empire State Building in New Jersey, try to put it on a truck and take it to New York City. Yet we've been doing things the same way in outer space for the last 70 years. We build it on the ground, we cram it inside the biggest rocket possible, and then we launch it into outer space. So the size of things is very, very limited. And you know, the largest object in outer space, the International Space Station, is only about 1,000 cubic meters or so. So if we hope to truly have a new space economy for things like in-space manufacturing or large data centers, or you know, even tourist applications or large-scale research and development, then we have to be able to learn how to build in situ, and that's what our company is really founded on. And I'm going to throw up a few slides here, hopefully, if all goes well, to talk a little bit about that. So let me bring those slides up, and Sharon, please let me know if when you can see those slides. All right, should be sharing. Hopefully you got it. Looks good. Can we try to maximize this? Sorry. Second. Okay, for some reason the slides aren't maximizing, so I'll do the best we can for you to be able to see these. Okay, there we go. So again, you know, our goal is to be able to defend, service, and build things directly in outer space. And why in that order? Why defending, servicing, and building? Well, whether we like it or not, unfortunately, space has become a warfighting domain. You've seen this, you know, with the foundation of the U.S. Space Force. You know, we know that there are satellites that have offensive and defensive capabilities from multiple nations in outer space and things like that. So unless we can operate freely, peacefully, and safely in outer space, we must defend that high ground. Servicing things in outer space, you know, all economies rely on infrastructure and servicing, so the ability to fix things in outer space so they're not one usage is really important. And then building in outer space, as I mentioned before, is fundamental to all economies to have large infrastructure in outer space. And you know, we're starting with the defending piece, and the U.S. and our allies are truly operating in the blind in outer space. The way we do business today is quite antiquated for tracking, never mind understanding the capabilities and intent of those that wish to do us harm in outer space. And I think in analogies similar to the Cuban Missile Crisis from back in the 1960s, when the Russians were stationing nuclear weapons 90 miles off the shores of the United States. And without a capability like the U-2 spy plane, we would never have known. And today, in outer space, we really don't have a U-2 spy plane to be able to understand truly what our adversaries' capabilities are. So what we've done at ThinkOrbital is take a fairly common phenomenology on the ground of X-ray imaging and apply that to outer space. So the ability to actually look inside our adversary satellites from distance is the technology that we are working on here to be able to determine their capabilities and intent. So not only can we look inside those, the way our multispectral detector works, we'll be able to tell what the materials are on board those satellites as well, and provide relatively high fidelity imagery on the order of 3 to 5 centimeters resolution at distances of over 10 kilometers. So these are stationed on 2 highly maneuverable rendezvous and proximity operations host satellites. We're working with a company called Argospace that is building those, but there are several folks that are building those types of capabilities. And for those who aren't familiar with the space domain awareness market today, it's something that's grown well, not only on the military side, but just from a debris characterization perspective, collision avoidance perspective, things like that. That video that's playing on the right-hand side is pretty much how space domain awareness is done today. We track objects from the ground, typically with a series of radars and optical telescopes. And one of those blips kind of passes through that field of view, then we kind of can characterize which object that might be. So as you can see, right now we've got kind of a perhaps where an object is and maybe what it is from a catalog perspective, but to know truly what its capabilities are and intent are, we have very little capability to be able to do that. So our company is building these satellites. We have 2 launches to test the capability next year that we're very excited about, and 2 launches in 2027 as well. So that's kind of the space component of what we're working on. We've taken the same capability that we've built for outer space, which is small, lightweight, ruggedized, all of those kind of things, and have recently received an international patent to use that X-ray technology on drones. The ability to do this both on the battlefield for law enforcement capabilities and for things like energy infrastructure inspection, like wind turbine blade inspection, will revolutionize some of those industries. We're getting some really amazing results that I'd like to show you. Let me just show you kind of what the drones look like. You know, we've done a lot of experimentation with the drones, and it's a great precursor to doing things in outer space, because the drones, obviously you can land, we can look at the sources, we can tweak some of the parameters on how much X-ray energy and power and processing and things like that on the different images that we get. So a very powerful capability that we're super excited about. Here's some results from the initial lab testing that you can see. This is at about 0.6 meters distance. You can see a small satellite that we built, a CubeSat, and the ability to actually see inside not only the CubeSat, but inside the batteries inside the CubeSat. The valves that you see here, I can't tell you how many times I personally have been on console not knowing whether or not a valve for a spacecraft is open or closed because of some anomaly on the spacecraft. So the ability to know for certain before you take an action that may be irreversible on a spacecraft, I think is really important. So there are commercial applications here and our ability to truly understand what our capabilities are. Some of the range stuff here, here's a 30-millimeter bullet that we put inside of a metal filing cabinet, and you can actually see through the bullet at 10 meters away. And then right-hand side, some wind turbine blade information. In the interest of time here, law enforcement is also another great potential area for usage. You can imagine it's like a hostage situation where a perpetrator has a pistol, and you want to know if that pistol is real, if it's loaded, if it has bullets on it, and is there one in the chamber. And clearly, from 10 meters away here, you can see that there are bullets inside the magazine, and up top here, there's not one in the chamber. So I also wanted to say that we are still contemplating that longer term vision where we will be able to do in-space servicing and infrastructure. That piece of it is still alive. We were recently down at Marshall Space Flight Center in Alabama for NASA, where we did a demonstration, and for some reason the chart's not coming up, but got the spinning ball. But in any case, we mounted our electron beam welding gun on board a robotic arm, and actually that was an international partnership with the company in the United Kingdom, and brought that down to the Marshall Space Flight Center and did some robotic vacuum welding with them, which was a nice successful test. And then eventually, we will be building this large infrastructure in space, and you can go to our website, www.thinkorbital.com, to see how we construct these large footballs in outer space. If you think of a traditional football, your football, not an American football, a soccer ball, is made up of pentagons and hexagons. If you stack those flat and then launch that into space, and then use precision robotics to reassemble and mechanically latch those pieces together, then you have a rigid structure that you can weld using the techniques that we've been developing using electron beam welding. We've launched that electron beam welder into space twice now, returned samples for NASA and the European Space Agency, and the ability to build a structure on a single launch that's over 4,000 cubic meters and assemble that in 8 weeks will change the way we think about infrastructure in outer space. So with that, I always like to brag about our small but mighty team. We've done this 2 launches and 2 launches on the books in 3 years, on very little funding with some government grants and some venture capital backed funding. But we are getting there, and we're truly inspired by the work that the folks on this call are doing. But ensuring that we have the ability to really extend humanity's reach, protect the high ground of outer space, and build the infrastructure for the future of the new space economy is what we're all about. So with that, I'd be happy to take any questions and really appreciate your attention here.
Thank you so much, Lee, for that awesome presentation. Thank you so much. We really love what you're doing. Thank you. So I would love to ask our participant, do you have any question? So please, you have just raise your hands, and then I'll call you to go on with your question for Mr. Lee before he takes his leave. Thank you.
Well, I must have answered everyone's question on how we're going to go do all this stuff. My goodness, I want Sam to ask me a really hard question on the thermal environment or something like that. How's that?
All right. So is there anyone? Okay, Dr. Taufik just raised his hand. So, Dr. Taufik, you have the floor, sir.
Oh, thank you so much, Mr. Lee, for the wonderful presentation. I totally enjoyed it. Well, I'm not going to ask any technical question. I just wonder, how long has the ThinkOrbital company been in existence for?
Yeah, we started in 2022. Really got funding in 2023. We had 2 launches in 2024 and have 2 launches in 2026. So it's been happening relatively quickly. If there's anything I learned at SpaceX, it's that speed is the secret weapon. So we build a lot, we test a lot, we fail a lot, and we recover and we get back as quickly as we possibly can.
Congratulations. For a fairly young company, you're doing quite good. Congratulations.
Thank you very much. I appreciate it.
All right. Thank you, Dr. Tak, for the question, and thank you, Lee, for answering that. So I have one question here from one of our Chinese participants. So he asks that, are you planning to build a vacuum chamber in space for welding and repairs?
Well, the good news is you don't really need a vacuum chamber in space because space is in and of itself the perfect vacuum. So no need to build it in space. We have several vacuum chambers here in our facilities in Boulder, Colorado, in the United States, including one that we just activated, which is a unique vacuum chamber. It's a 10-meter long vacuum chamber. This gives us the ability to test our long-range X-ray capability that we hope to operate at over 10 kilometers someday. We're doing it at 10 meters. I wish I could build a 10-kilometer long vacuum chamber. That's really not practical to do, unfortunately. And we will use that 10-meter vacuum chamber to test the characteristics of the long-range X-ray and then extrapolate those results out to over 10 kilometers.
All right, thank you. And he asked a question earlier on. He says that, is that a commercial space station?
It can be a commercial space station. It can be a private company space station. It can be a government space station. It can be any one that needs large volume in outer space. We will be there for you.
Okay. All right. Thank you so much, Lee. Thank you for the awesome presentation. We really appreciate you. So we're going back to the creative and innovative show. I'll be calling on the last participant to.
Hello, sir.
Hello, okay, I'm with you. Marvelous. You
I
can
think
go on.
Someone is raising his hand up. Someone.
Okay, Samuel. All right, Samuel, please kindly go on with your question.
All right, Mr. Lee, thank you very much for your presentation. It was really nice. I don't know if it's going to be possible to maybe get access to the slides to get more acquainted to what you guys do, just so that one can see and maybe a way to contribute, a way to, just to know more about it. Thank you.
Yeah, I think visiting the website has a lot of information on there at www.thinkorbital.com. It has just about all the information that's you saw in the presentation today is on the website, including some cool videos that hopefully can help explain things. I didn't have the time to show everything today, but the website, Samuel, is a great source of information there, and you can always reach out, and I'm happy to answer any questions.
All right, thank you, Samuel. I hope that is actually answered for you.
Yes, very much. Thank you.
Okay, you're welcome.
Yeah.
All right. So we'll be going on to call on Dr. Ashwaya Dara to come up with her own demo presentation for the creative show. So let me just read our presentation. Our biography on here. She was actually one of our speakers that we had on the first day. So let me read it. Dr. Ashwaya Dara, the founder of Academy Innova World, an assistant professor, Department of Aerospace Engineering at Udustin Institute of Technology and Science, India. Dr. Dara is an excellent academic and researcher currently serving as an assistant professor, Department of Aerospace Engineering at Hindustan Institute of Technology and Science, and also acting as the founder of Academy Innova World. She has dedicated her service for more than 11 years in the aerospace domain. She has authored 3 influential books. Wow. Essence of Aerospace Engineering, that's the first one, Aircraft Design Guidebook for Freshmen, and Overview of Aero Modeling. Our contributions have been widely recognized, any accolades such as the Kampala Shwala Award and the Best Teacher Award. Dr. Dara's research is at the forefront of industrial engineering innovation, with a focused interest in the application of artificial intelligence and machine learning to aerospace vehicle design, including aircraft, UAVs, and rocket thrust chambers. She leverages multi-criteria decision-making (MCDM) techniques for design optimization, a theme central for her PhD thesis on the machine learning-based design for wide-body aircraft. Our prolific research outputs includes numerous publications in reputable international journals, and a seed fund project on drug prediction modeling. As a recognized ATLA Innovation Mission Mentor of Change, she actively guides students and aspiring entrepreneurs, fostering a spirit of innovation. Dr. Dara is a dynamic force in aerospace education, a skilled educator, and innovative researcher at the intersection of AI and aerospace, and a dedicated mentor shaping the future of technology and its entrepreneurial applications. So, Dr. Dara, the floor is yours for 20 minutes so you can go on with your demo presentation. Thank you.
Thank you so much for a wonderful introduction. So as he said that I'm the educator, so around 11 years. So I have been doing that for quite an 11 years. So I'm learning student psychology, and I have been in this field, aerospace and aeronautical field, for quite a long time. So what I have understood in this phase, as Mr. Lee has presented an amazing presentation about this international space stations and rocket launching, and the previous speakers also spoke so many things. Now, I hope my screen is visible to all of you. Now, my concept is very clear to initiate the ground level foundation. So I basically expertise in the field of education. So I have one space capsule, I have one rocket, and I have some spacecraft, you can see, and I have some modules with me, right? So when we talk the word called aerospace, by the name itself, it's very complicated. So I am here to present STEM empowerment education based on AI innovations and how we can improve next generation space workforce. So before we get into this Lee's company, that is the ThinkOrbit, or working, what are the scientific terms that is related to this international space station, or building a rocket or a space capsule, or many other complicated. So my job is to make it very simple and educating the ground level foundation, whether it's a K-12 students or maybe an researcher. So here I present a concept called Skyfi. That is my company, as they have said. I'm the founder of Academy Innova World. So my company works on R&D and developing on web-based applications using augmented reality, XR, mixed reality, extended reality, and other 3D simulations. So I hope you can see my screen. Is my screen visible?
All right, it's just to be turned on.
Okay. I think I will remove. I hope now my screen is visible to all. Yeah. So I have a very simple feature. So where students can engage learning on the basis of, not a like kind of boring things. Aerospace and the space exploration is a very, interesting thing. So you have a two type of modes. One is a learn mode and the game mode. So here you can see different kind of flight vehicles are there. So choose any one of it. So this feature says that if you select this aircraft, so you can, aircraft will be popping up. So there are some lists, you can choose a different model of aircraft. For an example, Airbus 380 or maybe Boeing 737, or different models will be popping up. Not only that, there is also an AR feature and 3D hologram feature, which will narrate a story on basis of it. So you can explore the entire parts of it. And if you click some particular point, suppose I'm clicking on the engine, a description about the engine will also highlight over here. So all this PDF or this wireframe, you can also download the notes and everything. Now for an example, helicopter. So I clicked here, helicopter. So such thing is also visible. So you can explore each and every components of a helicopter. Similarly, we have satellite. So each and every component, if you choose, you will find this layout. Now this is all about the app. And this is an app which we can, explore and learn with a 3D simulation. So our course, our Academy Innova World is not only limited to this. I would like to also walk you through our courses as a beginner. So we have given our product name called Sky5. Our vision is very clear to beginners or the experts. We want to give an effective learning experience where they will have a very deep learning experience. So if you see, if you have been a teacher or maybe a student, a teacher is teaching something today and tomorrow you may not recall that. But if you have a real-time practice, hand-on practice on the same time, or engaging learning, so definitely you will really enjoy the learning. On the same time, you will not forget the concept. That is our mission and vision of our this product. So as you can see already, it is this product is almost 3-year old, and already we have won a lot of awards from it. And some of the features that has been integrated, the first features is you can learn from anywhere, accessible online, as you can see the URL over here. Stress-free conceptual learning. This conceptual learning is very, very important, which will hold the foundation. And integrating AR and VR technologies, gamification module. Gamification module is, as you know, that engagement of the students with the teachers and the connectivity with the concept is very, very important. We don't want kind of board kind of slides or something. Okay, so you can see our engaging, how many people are following. There we have different certified experts with us who is making this module. And very interestingly, if you scroll down to this website, you can see a lot of aerospace contents which is available in this website, including hypersonic aerodynamics. And I would like to take you the course, which is right now freely available, is that design and development of UAV. Suppose you want to learn more about this design and development of UAV. Now you know how this UAV nowadays play a very vital role, not only in the civil or commercial side, potential pivotal role in this defense sector. So if you are really want to engage yourself or learn more about this UAV, if you're a beginner, so you can see the course details, the syllabus or the modules. You can see what are the things has been covered. Then you can go to this learning mode. So learning mode, whatever the modules is there, you can see all and each and every modules. So this module is not only with the PPT, but also you can look a brief what is going to be in this module, right? With the entire animations, no boring slides, right?
Даже ты про БПЛА рассказываешь. Ну, это уже неинтересно.
And here you can see, if you want to know more about this UAV technology, you can learn everything from the website, starting from the scratch. What is UAV drones, the rules in India, and you can further explore this website, that what are the other things. And you can test your knowledge. This is the most engaging part of our system, is that you can see a crossword. So the questions will be here, and when you click onto this question, here you can tap and give. So whether you want a across one or down one, you can give. And you can also see further assistance. You can join with your friend, or else if you are a new or beginner, if you want to know all the answers, you can go and click this reveal answers. So each one, suppose this is one, right? So it's been clicked here. So you want which one you want to reveal. So enter answer you want to reveal, or only the first letter you want to reveal. So all the letter checks, everything great. You can access with your friend, and you can add manually and connect it with them. So such kind of features is there. Not only that, with the crossword, here we have some words have been fetched here. So here you have to find the with the cross that where these words are connected. Suppose we have air. Okay, so you have to find where the GPS is there. So accordingly, you have to find this module. Not only that, we have another interesting modules like MCQ. Once you complete the module or give the answer, and scroll down, and submit, you can see the score, and finally you get to see the right answer. So not only that, for other core subjects, you can also have this 3D experience. So if you click onto this panel, you will know what are these components are, how they work, what are this other, you can magnify this and learn more how this component really work. And here we have another interactive module of wind tunnel. So here you can simulate it with different models, changing, here you can see the units, like changing these dimensions of it, and you can learn the effective module of the study of this wind tunnel. And also you can perform the test as well, right? So this is just a brief. And as you can see, our InnovaWorld YouTube channel, we have started in the year 2017. And now we have integrated everything in our app. And also we have integrated in our website module, which we have given as academyinnovaworld.org and Skyfi. So here you can go. This is our website. I think it's a small demo. If you have any further queries, I'll be happy to answer for it. Yeah.
Wow, 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 wow. That's really a great one from Dr. Dara. Your presentation was really wild and brilliant. And I really love your demo. It's very valuable to those who are actually in the education sector and even people that actually want to know more about space and aerospace, maybe aviation. So that's very, very remarkable. Well done, well done. So I'd like to
Yes.
ask, does anyone have questions
And
for her?
yeah, I would like to say in this last 2 years, we have connected with 14 schools, and they have really got our products and they are using it. It's like we have both in web-based and also in app-based. So we have a customized module also. So they can use gamification. Not only that, mathematics is also included. So this is just an demo we have shown here today. Yeah.
Oh, thank you so much. Thank you so much. So I'd love to ask, like I said, does anyone have a question for her or maybe recommendation as well? All right. So let me call on Dr. Moloye.
Thank you so much. Thank you so much, Dr. Dara. That's a very wonderful presentation. And I totally love the website. I'll definitely recommend it to my students. I'll try to contact you to for that discussion. Thank you.
Thank you so much. Yeah.
All right. Thank you so much, Doctor. Thank you. Thank you. Thank you.
Thank
All
you,
right.
sir.
So, okay, is Neil still on the call? Does he have anything to say? Or Rama, anyone?
Yeah, I am still here. Very interesting, very thorough. Yeah, beautiful. I was thinking about our space planes. You know, when I saw your vehicles, so helicopter, UAVs. So maybe we can talk about that another time.
Yeah, sure. I'm looking forward. Yeah.
Thank you.
Yeah.
All right. Thank you. Thank you. Thank you. Okay. So yeah, we'll be going further from here, and we're going to our panel discussion. So we have 3 different panel discussion, and each panel discussion have the speakers, let me say panelists. So the panelists are those professionals that were opportune to speak at our day 1 and day 2. So for the first panel discussion, our focus will be on emerging technologies and sustainable space systems engineering, which is on also innovation in aircraft design, satellite systems, assembly, and integration and verification. So the speaker selected for the first panel discussion is number 1, Dr. Taufik Amole, who is the coordinator, Department of Aeronautical and Astronautical Engineering, Kwara State University. The second speaker is Marvecx, who is the CEO and co-founder of the Radiation Team, Limited Liability Company in the United States. And the third speaker is Raman Murali, that's the head of AIV at Space Inventor AS Denmark. And the first speaker we have here is Dr. Christige Moll. Please permit me if I don't actually get the